question number 8 now, and we need to find the average value of g on the closed interval between -2 and 3. So between -2 and 3 on this function g, I'm wondering, what is my average value? What is the average value on this interval right here between -2 and 3? Now, I'm going to rewrite this as I already did here. Instead of asking the average value of g, I'm going to say the average value of f prime of x. Because I know that you know f prime of x represents the slope of f of x on, and I'll just continue to put my closed interval here. I'm looking for the average slope of the function f on the interval between -2 and 3. So how do I find the slope? That should be the change in the y's over the change in the x's on this interval for the function of f. I'm looking for the average value of f prime. That means I want the average value of slope, which means I now need to figure out what the slope of f is. This will be f of, my last number here, 3, minus f of -2, all over 3 minus -2. And it's okay if I turn it around. I just like to think of this as being an interval from a to b and talking about f of b minus f of a all over b minus a. So I need to go back over to my work over here, and I need to find f of 3. f of 3 was -0.8, so I substitute my -0.8 in here for f of 3, minus f of -2 is a negative, I'll put my parentheses down here, -14.5, all over 3 minus a -2 becomes 3 plus 2, which is a 5. This is a -8 plus 14, -0.8, sorry, plus 14.5. So I have a negative value and a positive value. I have to find the difference between those. That's going to give me a 13.7, and it's positive, divided by 5. So 13.7 divided by 5, I think I'm going to, I'll just do that right here for a second. 13.7 divided by 5. As a matter of fact, I think I'm going to do something a little different than that. I'm going to double the bottom and give me a 10. I'll double the top. That'll be 27.4. And now I can take 27.4 and divide by 10 real fast, simply by shifting the decimal one place to the left, giving me 2.74. So 2.74 ends up being the average value of g on -2, 3. So this is 2.74. I'm okay with 2 decimals here instead of the rule of 3 because that is the exact answer, 2.74. It's not a rounded value. I can leave it as 2.74. Now, I haven't really talked to you a whole lot yet about the average value, but I'm going to bring it back into focus here. And I didn't even give you any integral formula for the average value yet. That's coming to you, or perhaps, depending upon how you're watching your videos, maybe you have seen it already. But the idea behind the average value, if you look at the integral itself, is to look from -2 to 3, and that's all I'm going to sketch, -2 to 3. So -2 is here, 3 is here, and it looks like this graph goes up here and comes back down, something like this. Okay, this is -1, 0, 1, 2, and I'm not quite sure how high it goes. Let me see the original question. Looks like it's going up to about 4. So on the original graph, this is what it looks like. And it looks like the graph goes up to about 4 right here, so that this is the point 0.4. Okay, so the average value of g, and this is g. The average value of g is the average height on g as you go around. Now, the average height, I'm telling you the answer is 2.74 because we thought it out using the concept of slope. And we got 2.74 is right around here someplace, maybe a little bit higher, 2.74. So I know that the value of g is lower at some points, it's higher at some points, and it's lower at some points. However, the average value is right here. And what that gives me, believe it or not, is really kind of cool. I'm going to draw this one more time. Matter of fact, I will do it, I'll try to do it right next to it so I can compare it with you. -2, 1, 2, 3, and then up here at 4, right? Okay, so this graph, this region C is kind of doing this. All right, and here's my 2.74. So the average value of G is a particular height on G that says that the area of the rectangle that you would form, and that's why I wanted this little piece of chalk, the area of the rectangle that you would form with this particular height, this G height, just like that, just like this area of some rectangle with a base going between -2 and 3, because those are your limits from A to B, is going to be the same area is what you have under the curve. It says these two areas are equal. Now I get you that I have a little bit hanging over here that isn't covered, right? But that's okay, because I have an area on both sides that I could literally like cut and paste, pull them off, and shove them in that area. These two things end up being absolutely identical. So wherever the area under the curve would match the area of the rectangle for the same interval between -2 and 3, this height value right here, this height of 2.74 is called my average value. Average value of what? Average value of G. It's the function you're playing with, the picture that you're playing with, the graph that you're manipulating and finding the area underneath. The average value of whatever function you're playing with is the height of the rectangle that you would have to use in order to form the area under the curve. This gives us what we consider a formula for an average value. They tell us that, well, I'm telling you, forget they tell us. I'm saying that area of the rectangle has to equal the area under the curve. So the area of the rectangle has to equal the area under the curve. The area of a rectangle is base times height. The base is whatever your B is over here minus whatever your A is. So the base, I'm going to just write base times height, BH. You know what? Maybe I shouldn't write BH. Maybe I should write base times height. That would be a good idea. Base times height. The base itself would be a 5 because it's 3 minus -2. Or in terms of A and B, it's B minus A. And the height, this height, is my average value. So I'm just going to say average value is equal to the area under the curve. And we already know that to be the integral from A to B of whatever function I'm playing with. And in this case, it's g of x with respect to x. Now, a weird thing is that both, when you look this formula up in a calculus book someplace, you're not going to see it talking about the area of the rectangle equal in the area under the curve in very many books. Or maybe I'm wrong, maybe you'll see it once in a while. But I like to think of the average value theorem saying that I'm going to have the area of a rectangle equaling the area under the curve for some height of some rectangle with the same interval. Okay? The formula that you'll find someplace will divide both sides by b minus a, and they will give you, and I'm going to erase over here for just a second if you don't mind, because I'll end up doing it anyway. I have b minus a times my average value is equal to the area under the curve between a and b of g of x dx. And what they end up with is they say divide this by b minus a to solve for the average value. Divide this by b minus a, which is kind of weird looking, isn't it? So the average value equals, and we're going to make it nice and neat, we're going to call it 1 over b minus a times the integral from a to b of g of x dx. And this gives you a formula for the average value, which is a really cool formula. You'll see it often enough. However, I kind of like this a little bit better because it really depicts what it is you're talking about. So I'm going to go back to the question. I'm going to use the formula and get the job done. Again, this is more of an algorithm in order to plop the question into the format and not have to think a whole lot. My average value is 1 over, this is A, as negative 2, B is a 3, so this is 3 minus negative 2, multiplied by the integral from negative 2 to 3 of my G of x with respect to x. Now we already know this integral between negative 2 and 3. We already know what this is. We already found that, or it was given to us right here. It's 13.7. This gives me 1 over 5 times 13.7, which is the same math I ended up coming up with when I was doing the slope formula with my function f. This is 13.7 divided by 5, which is still giving me that 2.74 for my average value. So I can find my average value 2 different ways. Again, my favorite thing is the fact that the area of some rectangle has to equal the area under the curve. And the graphs have to match. Okay, if this is G, that's G I'm talking about too. There's no back and forth between the first derivative and the original function or anything on here. It's whatever function I'm playing with in both cases. Area of a rectangle is base times height, and the height of the rectangle, the height of that rectangle is called my average value. So we got the average value is whatever height for your rectangle, where if you find the area of this rectangle, you get the same area that's bounded by the curve itself, x equals a, x equals b, and the x-axis. Okay. Well, for question number 8, I didn't box the answer yet, but the average value is 2.74. Okay? And I think it makes sense. Somewhere between 2.5 and 3 in there, that even looks like the same area. Okay? We're going to wrap this up in the next video, and it'll be all done.